Okay, let's rewrite sine to the fourth power of 3x as an equivalent expression with exponents no higher than 1. Okay, so we're going to start with sine to the fourth 3x. And we want to reduce the power on this exponent. First of all, realize that sine to the fourth 3x is the same thing as sine of 3x, the whole thing to the fourth power. And I want to remind you about an identity. It's called the power reducing identity. And it says that if you have sine squared theta, then that's equal to 1 minus cosine 2 theta all over 2. This is the identity we're going to use. And the way we're going to be able to use it is by thinking of the sine of 3x to the fourth power as sine squared squared. So sine of 3x, I'll put the exponent of 2 here, and then on the outside, think of another exponent of 2. So when you take something like y squared, there's a property of exponents that says you multiply the exponents. That's what we're doing here. So sine squared squared is sine to the fourth power. Okay, so now what we can do is we can use this identity to reduce this power inside these brackets or these parentheses right here. And what's acting like theta in this case is 3x. That's your theta. So we're just going to plug in the right side of this formula using 3x for theta. So if we do that, working downwards, we'll get, okay, the whole thing on the outside has to be squared. So I'm going to change to brackets. And then on the inside, I'll put the power reducing version of this, which is 1 minus, okay, cosine of 2 theta, but theta is 3x. So it's this 2 right here, and then 3x where the theta is, all over 2. And so that becomes, if you think about it, 1 minus, so if you want to, you can put another little set of brackets there or parentheses there. Oh, it's the cosine of that whole thing. 2 times 3x is 6x. So you can think of it as 1 minus cosine 6x. And really those parentheses aren't necessary, but it doesn't hurt to have them. So you get 1 minus cosine 6x all over 2. That whole thing brought to the second power. And the problem is we're not allowed to have exponents bigger than 1, so we're not done yet. But I think the way I'd like to rewrite this is to split up the exponent. The exponent splits up over division. And so I'm going to rewrite this just using a set of parentheses. If I split up the exponent, in other words, I can square the numerator. Notice what I did here. I'm not being consistent, but I dropped these parentheses. And then I put parentheses around the whole thing. And I'm squaring the numerator, the entire numerator, and then I'm going to square the denominator. And let me shrink this down a bit so I can try and fit everything mostly on one screen. Okay, so in the denominator, I get 4. 2 squared is 4. But dividing by 4 is the same thing as multiplying by 1/4. So I'm just going to pull a 1/4 out front. And then I'm going to go ahead and square 1 minus cosine of 6x. Square the old numerator. Okay, how do I do that? Well, remember the formula a minus b, the whole thing, quantity squared? Remember that's equal to a squared, square the first guy. You take the first guy times the second guy, double it, and then subtract it off for the middle term. And then you add in the last guy, which is b squared. I'm going to use that formula here where a is, what's acting like a is 1, and what's acting like b is the whole thing cosine of 6x. And so what I'm going to do is I'm going to multiply this out. I'm going to expand this out. And I get 1/4 times the quantity. Okay, a squared is just 1 squared, 1. minus a times b doubled minus 2 times 1, well, 2 times 1 times cosine of 6x, which is just minus 2 cos 6x, and then plus b squared, which is cosine squared, and then the 6x. And so now maybe you see the problem a little better. We're not allowed to have this for some reason. So we got to get rid of it. Well, on this guy, then we can just apply the power reducing formula, but it's not sine squared, it's cosine squared, but it's a very similar formula. The formula for reducing cosine squared of theta turns out to be 1 plus cosine 2 theta all over 2. So that's the formula we're going to use here, but what's acting like theta is 6x. So that's what we plug in for theta. Okay, so we do that. We still need the 1/4 out front. We need the 1 minus 2 cosine 6x. That's not going anywhere, just copying that down. And then I'm going to replace cosine squared 6x with the power reducing identity, 1 plus cosine of 2. And then I'm plugging in, for theta, I'm plugging in 6x. So I'll temporarily put in a set of parentheses there. And then I'll put in temporarily put in a set of brackets there, to emphasize that we're taking the cosine of 2 times 6x, that whole thing in orange brackets. And then that's all over 2, close parenthesis. So everything in this box right here, cosine squared 6x, I replaced with 1 plus cosine 2 times 6x all over 2. And then just rearranging things a little bit, I can go ahead and multiply the 2 times 6x to get 12x, and that's going to be 1/4 1 minus 2 cosine 6x plus 1 plus cosine of 12x. And notice I can drop the parentheses there. When it's a product here, I know I'm taking the cosine of the whole thing. It's understood. And then that whole thing divided by 2. Or you could write it as that whole thing multiplied by 1/2. So you could change this division by 2 into multiplication by 1/2. There's no problem doing that. Oh, and I also need to close this parenthesis here. And then, how did they write it in the back of the book or at the end of the book? They probably multiplied out the 1/4, but before you do that, rewrite it the inside as 1 minus 2 cosine 6x and distribute this 1/2 to get plus 1/2 times 1, which is 1/2, plus 1/2 times cosine of 12x. And now distribute that 1/4. Well, you know what? Before you distribute that 1/4 to every term, notice that you have a 1.5 here. 1 plus 1/2 is the same as 2/2 plus 1/2. That's the same as 3/2. So let's make that simplification. Before we multiply out the 1/4 and get 1 minus 2 cosine 6x. Sorry, let's change that 1. Let's go ahead and do it right there and change that 1 to that 3/2 that I mentioned. Because 1 plus 1.5 is, or 1 plus 1/2 is 1.5, which is 3/2. So I added these guys together, got the 3/2. Minus 2 cosine 6x didn't go anywhere. And then I still have a plus 1/2 cosine 12x. And then, by the way, if you get this far, that's good. You can stop there. But just to see how they got the answer at the end of the book, go ahead and multiply out, if you want, go ahead and multiply out that 1/4. You have to distribute it out. And you will get, okay, 1/4 times 3/2, just multiply straight across. That's 3/8 minus, 1/4 times this minus 2 here. That's minus 2/4, which is 1/2. And then 1/4 distributed over 1/2 is 1/8. And then you still have the cosine of 12x. And this is equivalent to what's written at the end of the book, and this answer is just fine. Of course, if you had stopped here, that answer would be just fine too.